Welcome, ladies, gentlemen, and fellow Earthlings. I'm Paul Mayer. With me, as always, is Harrison Lambert. It's my pleasure to welcome you to another weekly edition of the Space Times podcast, where we discuss the industry, business trends, and everything happening in space and our times.
All right, Paul, we got some interesting topics to discuss for this week. A lot of the big moves, a lot of the patterns that we've been seeing over the past week or two seem to be related to changes in the military networks that are being deployed. So proliferated war network primarily, but also some other military assets for in-space communications. There's also quite a bit of movement in the launch vehicle segment across China, Europe, and America. So it'll be interesting to see if there's any patterns that we can find there. But to start, we'll just point out that Terran Space has launched 21 new satellites into the Tranche 1 of the SDA Warfighter Network. This is just after York Space launched 21 satellites for that same Tranche 1 of the same network. So it looks like it's kind of a competition between York Space, which is Northrop Grumman, and Terran Space, which is Lockheed Martin, to see whose satellite performs the best for this distributed communication network. We didn't see as many details from the Terran Space platform, but the York Space had some pretty clear pictures where you could see they had some high gain antennas for communication and laser terminals for inter-satellite communication. So I would expect Terran Space to be a very similar design. So I'm assuming that having both launch them together is to kind of see whose satellite performs the best, or possibly even could the two satellites perform together, since military government, they've been very persistent about having multiple suppliers for each asset or aspect of their space assets.
Yeah, the single failure point challenge in military has become more and more of a priority in the supply chain and value chain design here. So to your point, the likelihood that the proliferated war network winds up picking a single winner and going with a winner-take-all sort of scenario is really low. It's much more likely that there winds up being, okay, hey, here are the 2 or 3 players that we think are actually going to win. Here are the 2 or 3 players that we want to continue to work with. And what's more important than just having these 2 or 3 different options is that those options continue to sort of work together. So it would make perfect sense for there to be diversification across the actual proliferated war network providers themselves. And it would, while it would sort of further commoditize the assets and the hardware, it would make perfect sense for the end customer if those different assets were able to work and communicate together, even if they're not performing at 100% capacity. The Lockheed model working with the Northrop Grumman model, 70%, 60% capability in interchangeable communication there would still be a massive win for all parties involved here.
No, I think that's kind of the right way to look at this. Is it's just a layer of the resiliency that I suppose the United States Space Force is trying to build into their system. Granted, this is the SDA Space Defense Association. That group that's buying all these satellites and developing the technology, but it ultimately is going to be used for military networks.
Right. I think,
and they own the satellites, so they can kind of force the suppliers to play nice together. It's less of a competitive kind of market when it's controlled that tightly by the government.
Right. I think we're going to continue to see "quote unquote" resilience be the key factor here.
Yeah, because Starshield also had some updates, some news in the past week. I think they've tried to keep it hush hush, but people were picking up on it because it's very unusual. But there was some news about Starshield using the S-band for downlink of data, which it's typically only used for uplink, and pretty much every satellite uses it. It's a pretty low bandwidth frequency, but it's it's easy to allocate space for all the satellites to use it. But this is a bit odd because if we have these proliferated kind of Starshield satellites everywhere, broadcasting on a frequency that's frequently used for receiving data, there's could be a lot of crosstalk between satellites, which would not be great, especially given how many how proliferated the Starshield network could become. But it seems like there's some value in adding a new spectrum to the capability of communicating to satellites. I think when most satellites are, being jammed or having their RF rejected in kind of more common X and Ka and L band frequencies, it might be helpful to have an extra frequency available to communicate both up and down with a satellite. And Starshield, another example of a kind of proliferated space platform, government, but is produced by SpaceX, the of the Starlink satellite that they're able to use for these proliferated networks. So it further along in the deployment, and they're running different applications for it. And this might be a case of between and this SDA Tranche 1 made up of some of the bigger players. It doesn't seem like there's as much interplay between these two kind of space systems. But again, maybe the goal down the line is to have all these providers be interchangeable and just have that extra layer of resilience and not just having different providers so that if one can't supply, the other ones can, and having them able to operate in just about any frequency domain so that they can't be jammed when in operation.
I was not aware of Starshield playing in the S-band network at all, so they've done a reasonably good job of keeping that quiet. Do you think that's intentional, that they're trying to keep that capability on the hush hush, or is that more of a, how do I put this? Is this more of an intended feature, do you think, of additional capability, or would you suggest that this might be an emergency solution to a problem on orbit?
No, I definitely think it's not meant badly. I don't think it's there's not really much way to hide it when it's such a common frequency, and I think that's kind of what this news is people are picking up on it. I don't think we'd expect to get any more detail on what it is, how it's being used, since it's military application, and since it's such a highly regulated frequency, it's kind of surprising they're able to do this. But again, it's, as long as the military tells some of the agencies DC that regulate the frequencies that they're fine to operate here. There's sort of a third activity this week that plays into the same kind of resiliency of spacecraft, especially military communication spacecraft, which is that Viasat has indicated that they're going to move into military satellite communications applications. So traditionally, Viasat's geocom telecom provider for commercial communications. It was a bit odd, especially after talking about SDA Tranche 1 and Starshield and these like proliferated LEO comms networks, that the government would also be investing in these geocom satellites. But the purpose of them is to have a maneuverable satellite. So this is different than the traditional geocom that kind of just sit in one location. But we've been seeing in the past year RPO demos with the USSF and France, RPO demos with the USSF and UK, RPO demos from China with the Xi'an 21 and 25, I believe, to maneuver around spacecraft in geo orbits and interact with them. China showed they could do that with refueling, but they could very easily do that to disable one of our satellites. So this definitely seems like a move that's based off a lot of movement this year to show that geocom satellites are not as safe as they have been in the past. And to add maneuverability to them is to make them more resilient against that kind of attack.
It continues with the trend of additional capabilities in this figurative space capabilities arms race, both in military terms and in more commercial and scientific terms. The thing that I find so interesting about this move to the military satellite communications, though, is that Viasat has traditionally exclusively done the big geobirds, 2,000 kilograms, 3,000 kilograms. They've typically only done the most massive satellites that are out there. And explicitly, this new military satellite communications layer that they're doing is still intended to be geo altitude. They're still intended to be geobirds, but they're supposed to be substantially less massive. So all of this to say that being less massive will give them orders of magnitude more attitude control and maneuverability up at altitude. However, it's unclear as to how that change in mass affects the ultimate payload or the ultimate mission. That was one of the biggest challenges that I'd seen engineering teams encounter on previous projects, was using existing massive geospatial satellite heritage data as applied to smaller, less massive, different characteristic line projects. Some of the fundamental assumptions that you make simply don't pan out. For example, not to get too far down a rabbit hole here, but for example, the thermal systems and the structural systems for a lot of geobirds are separated by enough physical space and enough physical mass that there's many of these systems that don't couple together. So you don't need to look at the cross product between system A and system B. However, if you start working with a smaller bus, a less massive, more compact bus, system A and system B are closer together. There's less mass damping everything out in between. And so you really do need to actually look at how those two systems interact with one another and what the effective cross product from both a thermal and a radiative and a structural and a stiffness perspective can be. And a lot of the times the heritage data for those big projects where those systems are effectively uncoupled doesn't translate nearly as well when they do start to couple up.
Yeah, I mean, it'll be interesting to see how the design changes. It's an XK band platform, traditional, but a lot of the times when they build very large satellites, it's because they need large coverage. The bigger they can make it, the more power they have, the wider the coverage they have, the more customers they can get. But this being the military, that's not really their concern. So, if they can cut back on mass, it could open up the opportunity to use other launch vehicles. If they cut back on, the coverage, they can focus more throughput on specific areas, which for military applications is probably more useful, and frees up a lot of that design space to add that maneuverability, which is the key difference between what they've traditionally built.
The business case is very much there, but the technical hurdles are going to amount to a whole separate ball of wax for Viasat. So best of luck to them. I'm sure they're going to make a lot of progress and do really well on this. But having seen this and having worked on this sort of thing before, that is a very ambitious project. It's going to be a lot of work, and I'm sure Viasat is up to the challenge. Should be a lot of fun.
Yeah, I think it will be, again, the fact that we have such a diversity of space platforms to solve this military communication problem. I think having the traditional geo satellite in the mix, again, goes back to that resiliency aspect. It's hard to knock out a satellite in LEO and geo at the same time. So having a diverse group of satellites flying in LEO, along with satellites in geo that are able to avoid RPO, interference from other nations. All of these are just different facets of resiliency. And even on the launch vehicle side of things, we've seen a big move by Firefly this week. So some of these higher levels of this proliferated warfighter network are going to need capabilities of missile defense. It looks like just repurchasing a company that's already doing it, and from all that I've seen doing it well. I think this makes sense given their track record, a series of launches. So Victus Nox, and I believe Victus Haze hasn't launched yet, but Victus Nox was successful, which led to Victus Haze. And those two are rapid deployment of space asset missions for the U.S. government. Those would allow them to replace satellites that have been disabled in orbit rapidly with their own rocket, which again goes back to this level of resiliency. If any aspect of our system is knocked out, we're able to deploy it quickly back to that. In a really nice position because they're able to kind of capture some of the business around some of the other tranches that aren't already being addressed by Lockheed, Northrop, and SpaceX, while still building out their launch to kind of accommodate the tranche. So we see Terran Space or York Space, or probably not so much the other, use Firefly to rapidly deploy replacement satellites if anything's knocked out of that network. And I think the whole symbiosis of it is really cool. The fact that missile detection network of satellites could detect the missile, launched to destroy a portion of that network, and then trigger the launch of a satellite to replace it, before it's even destroyed, so that our networks never go down for communications and missile detection for our military applications.
Yeah, I think the Firefly acquisition is really interesting for a lot of those reasons. It boils down to fundamentally sort of a scope play in the marketplace. Firefly is buying SciTec Missile Defense effectively to try and sell more of Firefly's own products, and to then, using Firefly's sales channels, sell more of SciTec Missile Defense's products. Broadly speaking, that amounts to more of a scope play as far as a corporate merger goes. And so their desire to do so, I believe the deal is $300 million in cash, $550 million in Firefly shares, priced at $50 a share by the sellers. So lots of equity being handed over in this deal, and a lot of cash as well. But the intent is very clearly there to leverage Firefly's current capabilities and the current products that they have to address some of the same customer needs that SciTec is addressing. And to your point, the overlap in their different capabilities and the overlap in their customer sets means that they're going to be able to, together, if everything plays out the way that everybody wants, in the best case scenario, they're going to be able to solve a lot of problems for each of their customers with a now more complete vertical tech stack. So that ultimate customer sale is going to be larger. They're going to be selling a more inclusive end-to-end product, and the capabilities that you discussed of being able to more rapidly redeploy, to being able to more rapidly address and react, those capabilities are very much in high need as part of this figurative or potentially literal arms race in capability in the space race.
Yeah, I think it really, like the Victus series of missions is really cool. I mean, having a rapid deployment system, a couple of companies, Falcon's done some quick turnaround missions, but really the ones that were focused on it were like Astra, with their cheaper, smaller launch vehicles that can launch quickly. We haven't really seen them achieve that, but it seems like Firefly is doing very well to achieve it, and that gives us improvement the cadence. And we've talked about this before. The cadence is kind of what holding us back for a lot of our capabilities. We're approaching that from several aspects, like the tech to build up deployment, like Firefly is doing, or Starship talked about before, is that we just need to improve our launch site capabilities. We're pretty hamstrung to two main launch sites, being Vandenberg and Cape Canaveral. Apparently, there's like 20 launch sites throughout America, but we don't do for anything meaningful in military space deployments. So it's good to see that there's also some movement to improve those capabilities. X-Wing improved Vandenberg launch rate, and that's going to move them up to the hundreds of launches per year. Right now, they're at about 50 launches per year. So we're having a rapid increase in the capabilities of that launch site. It's a very tried and true launch site. So it's good to be able to see that we can get more out of that.
In addition to some increased throughput and some increased capacity to launch, SpaceX also, I believe it was earlier this week, but their most recent Starship test flight was also considered a pretty resounding success. They managed to get through the entirety of the testing procedure that they wanted to do for the launch. They managed to get through everything and to properly, I'll say, decommission the Starship upper and lower boosters and stages that they were launching, is if that's correct. But another big milestone, another big step forward. In addition to some of these updates from the States and US-based launch, there were also some updates from European-based launch. So Ariane Space has unfortunately seen a slip to their debut launch of the Ariane 64, the Ariane 6 rocket with 4 solid-stage boosters in addition to the baseline Ariane 6 rocket. That unfortunately slipped to 2026. The intended payload for that debut launch was a whole bunch of Amazon Kuiper payloads, and that's going to get pushed back to first half of 2026, I believe, at this stage, which will unfortunately further delay the full ramp up of Ariane 6 launches. But impressive that they've gotten this far and that they continue to make progress and gain ground here. It looks like they'll be about 6 to 8 months delayed on this, though that is more of a conservative estimate than not.
Yeah, it's unfortunate to see it fall behind. Ariane 6 is it's a very capable spacecraft. It's not, there's the launch vehicle. It's not terribly dissimilar from Ariane 5. I mean, I think from a design standpoint, it's very different. The goal being to have the cost of launching this vehicle, but it's still not a reusable vehicle. So the savings are not really, that significant. But I think it also means that it's not blocking them from developing those reusable capabilities, which we talked about the past couple of weeks, as they're starting to pour a lot of money into that and testing out a lot of the capabilities needed for that. What this vehicle is a large lift launch, heavy lift launch vehicle, which are pretty rare. There's not a lot of them. China's got the Long March, America's got the Falcon Heavy, and we've got a variety of others like the Delta Heavy, but those are pretty much all. So to have a heavy lift launch vehicle that's considerably cheaper than the last generation of launch vehicles is welcome. I mean, it's great to have that in the fleet. I find the 64 variant of the Ariane 6 particularly interesting because those 4 solid boosters that get added on, obviously increase the orbit ability or giving some of those some extra delta V to get to further locations. But from a business standpoint, I find it cool because those 4 boosters are coming from Avio as well, who we've been talking primarily around their Vega C launch vehicle, which is a smaller lift launch vehicle, but it's cool that Avio's supplying rockets for every size vehicle in the ESA or the EU's launch fleet. But it's just it's just another aspect of seeing Avio make some pretty big moves. In the same week, there was news that Ingegneria dei Sistemi was contracted to build a landing barge for Avio rocket. So it looks like Avio is moving full steam ahead with their reusable capabilities. We talked about it last week, but the Vega C has a reusable upper stage. So it's possible that this barge is to capture that upper stage. So really great to see Avio, working on large or heavy lift launch vehicles from them, while simultaneously working on smaller lift launch vehicles with reusable systems. So EU making moves across the map in parallel to try to advance their launch vehicles. Hopefully they can deliver a full-on system that's operational soon. I think they're targeting 2026 now for the Ariane 6. So fingers crossed they meet that deadline.
Yeah, as much as we love the Ariane Ariane Space and the Ariane rockets, it's great to see some more reusable capabilities gaining momentum in the European market as well.
Yeah, but even if they're trying to, it's hard to look at this and not think that they're just trying to catch up with the U.S. and SpaceX's launch capabilities. But
that's right.
It's still like there's still a need for these kind of solid booster, heavy lift vehicles. Like Lockheed or ULA still flies some of these heavy lift vehicles, so they're still capable. And even in China, who's arguably further ahead on their reusable launch vehicle capabilities, they're still investing heavily in these kind of solid booster based launch vehicles. Just this week, Orion Space launched Gravity 1 for the second time off of the Yellow Sea, which I found kind of funny because EU is trying to land their rockets on a barge. Meanwhile, China's launching theirs from a barge. It's really cool because not many countries launch from the ocean. America tried to with sea launch, and I think another couple of companies, but not very successfully. Whereas it looks like China's doing it quite well with the LOC. So Orion Space Gravity 1 is a launch vehicle that's a 3-stage launch vehicle. It's medium lift, so it's like 6,500 kilograms to orbit, which is pretty big. All 3 stages are solid boosters, and then they attached 4 solid boosters on top of that. So this was the largest solid rocket launch to date, and it deployed a Yunyao 1 weather satellite and a couple of experimental satellites to orbit successfully. So, I call that progress. It's pretty old tech, but having a strong ability to build solid booster rockets kind of never goes out of style. Like the reason that Avio keeps coming up, because there's still lots of applications for solid booster rockets, and Avio has shown that they're very good at it. A lot of the money that's spent on it is for missiles, but we're seeing across all nations that the use for it in launch vehicles is still important. America's not out of the loop on this either. They have the SLS. The SLS is a solid booster based rocket. So, every country is seeing the need for solid boosters, and it's usually for some of these heavy lift vehicles. But it's very interesting to see the progress that's happening recently.
So a handful of raise announcements, handful of new contract announcements. We'll just go right through them here. But so Viridian Space, good friends of the show, just announced a 1.7 million phase 2 SBIR contract from the U.S. Space Force. Hopefully we'll be able to get Viridian Space on the show before too long here to chat about what they're doing. But the big picture is that they are solving some unique problems in the VLEO space. Super cool tech stack, great team. Additionally, Stoke Space announced a $500 million Series D with just a massive amount of money, but they have raised almost a total of $1 billion, and it's being used to accelerate the development of their Nova rocket, which is intended to be fully reusable and capable of, I believe, launching and deorbiting medium lift payloads.
Their tech is also unique, and I don't think they've ever launched anything to orbit, but they're also trying to solve the second stage reusability problem. Like we just talked about, Vega Seeds doing that, but I think Stoke Space is trying for larger launch vehicles. So, their tech is to have a bunch of smaller thrusters, so it's easier to lose some and still recover. And there's some other benefits for flying, in descent. But that's a huge raise. Hopefully it goes a long way to getting their tech working, because that's a technology that'd be great to have. I suppose Starship kind of gotten there just this week by showing that Starship could land. But it never hurts to have more companies that can compete.
More capable providers leads to more diversity, which leads to more resiliency and capability. Absolutely. But $1 billion raised since 2020 to solve this problem. So we're all really excited to see how Stoke Space is able to go about providing this value out of being able to launch and reposition and potentially deorbit different assets in a really environmentally and economically sustainable way. In addition, there were a couple of other notable raises out there. So Urban Sky closed, I believe, a 9.75 million Series A. That announcement went out earlier, and Auriga Space made a couple of public announcements here involving the raise of another several $1,000,000. So our friends over at both companies are doing well, and we're all very happy to see that. Additionally, the Indian startup Agnikul Cosmos has raised a $26 million pre-launch round to help with the development of their own rocket and get them to their first launch by the end of next year. So ISRO is really making a lot of progress with the Indian space ecosystem and is really helping to grow and scale the industry. We'd love to see it. Additionally, there were a couple of sizable contracts that we wanted to call out. Muon Space closed an almost $45 million US Space Force contract for what amounts to a data as a service, environmental monitoring, and climate response series of contracts. So some of the currently or previously existing weather and Earth observation satellites monitored by NOAA, monitored by the U.S. government ultimately wound up being shuttered and deorbited and defunded over the past several years. And so we're seeing private companies contract out more capital efficiently those same capabilities. And it looks like Muon Space is one of the beneficiaries of that privatization. So they're doing well there. And we'll be able to start getting those environmental monitoring benefits by the end of, I believe, 2027. Additionally, Spire Global won a $3.4 million EUMETSAT contract. They won the renewal for radio occultation for weather intelligence data. So another contract in the same weather intelligence, climate, and environment observation space that is open to more private and commercial players and problem solvers. And finally, Momentus Space here in the West Coast won a $5.1 million NASA award to host some microgravity payloads for in-space manufacturing research. We've seen a lot of microgravity manufacturing research being pushed for and done by the pharmaceutical industry and by a couple of other players looking for specifically PLAM and the like, other crystalline structure manufacturing winds up being much more controllable and predictable in a micro or zero G environment.
Yeah, I mean, a lot of these businesses are interesting. They're kind of all over the place in terms of technology, but they are showing patterns of what we've been seeing for the past few weeks. I mean, Viridian Space getting a contract for their air breathing thruster is very cool. They're talking about using it for VLEO applications, which are getting much more attention. We saw recently Space get a funding round for their air breathing thrusters, so it seems like there's enough demand here to support a market. And we'll see, whose tech wins out or how those work together to improve this capability. Since VLEO is a pretty new area of development for the space industry in general, we really have only seen Albedo and like GOES, like a Italian government satellite, fly there. It's a pretty rare domain. I mean, Urban Sky similarly is doing like weather balloons or balloon platforms. And we've talked a little bit about, space air hybrid systems. So we're seeing a lot of movement in VLEO in atmospheric applications. Those are really cool to see. Auriga Space is really out there for me. Electromagnetic launcher to get stuff to orbit. That's kind of wild. It's something we read about in textbooks in college, but you always get told like, yeah, it just doesn't work, physics. So I really hope they figure it out. Spin Launch is probably the closest company to them using kinetic launcher, but really trying to think differently about how we get stuff to space. It's great if it works. It's less fuel, it's more environmentally friendly, it's better scale, it's more scalable. It would just be an awesome capability to have in our fleet of launch capabilities. Muon Space winning this $45 million contract for environmental monitoring makes a lot of sense off the back of their Firesat contract. I know they got a lot of money for that, and they've put a lot of development into specializing their platform towards some of the instruments that are used for fire monitoring. It makes sense that they would want to leverage that network, since it's a pretty robust network of satellites in order to do the level of fire monitoring they need for that contract, to then use those sensors for other purposes and repurpose it as a data solution platform is really cool. I mean, not just from like a tech standpoint, the fact that like these relatively unique instruments are going to be useful for other applications, but also that they can make some more money off of this platform by selling that data as a service. It's, as far as I know, it's not really the purpose of their business. They're more of a spacecraft platform provider, but this looks like it could get them in a position where they are a data provider, which is typically a lot more lucrative business in the space industry. I mean, Planet and Maxar or whatever, they make a lot of money off of that kind of business. There's not a lot of companies that have really gotten a strong foothold doing that. I guess SpaceX with Starlink and whatnot would be another example. But that's where a lot of the money comes from. So hopefully that contract goes a long way to helping them out. Spire Global, great to see. I think we saw Planet IQ with a contract a couple weeks ago. So another radio occultation weather satellite. That's great technology. Hopefully having more of them means that we have better information about weather, which is always great. And this Momentus one is really interesting because I believe it would be on their Figuride 7 platform, and it plays well with some of the other two contracts they got this year, which was for large in-orbit deployable structures and a partnership with a robotics company. So if we put these three together and look at it as, robotics, large in-orbit structures, and on-orbit manufacturing, this is a really out there kind of tech to demonstrate, which, makes sense for their platform. It's a pretty high power 1 kilowatt satellite platform. It's originally designed for space tugs, but repurposing it to do large in-orbit structures could be really great. I mean, we haven't really talked about many companies working too heavily on this. Maybe Axiom would be the closest in terms of large in-orbit habitats, but these kind of large structures, it will be interesting to see what it's useful for. It is mostly the government funding this, so I would imagine it's for some space assets, but beyond space habitats, like the only things I can think of are large communication stuff or things like that. So, it'd be neat to see what they build with this. So to get into some of the more high tech stuff, away from the business deals, there was a really high tech thing that got some money this week, which was really cool since he's been working on it since 1979. Which is Franklin Chang Diaz got $4 million from NASA to develop his variable specific impulse magnetoplasma rocket called the VASIMR. This is a high thrust electric engine rated at 150 kilowatts. This is a pretty out there technology for electric thrusters. So it'd be really cool to see if we can get a test of this off of that 4 million. Seems a little low to actually develop something that can fly and test. So it's probably just more development of the technology itself. This seems more in line with some of the higher tech electrical thrusters that aren't often flown. Things like the electro gel or the electro spray thrusters that have a higher specific impulse. But this one seems, he's been working on it a long time. Is probably at the same level of development as those other options, and it'd be really nice that he could get it operational on orbit. A lot of these are just developed in the lab and tested there, and most satellites still fly Hall thrusters, xenon thrusters, like standard plasma thrusters, because they're reliable. So even if this is much better, it would have to be way better and just as reliable, and it's probably got a long way to go, but it's a really cool technology to see invested in. Atomic 6 has moved into qual testing and has opened pre-orders for a new space armor technology, which they are using to shield satellites against debris and micrometeorite impact. So this space armor is a new material, unlike the standard Whipple shields that are used primarily on the ISS and other large, valuable, expensive satellites, which use spaced layers of aluminum and Kevlar. This one is apparently entirely composite. It weighs about half as much, and it doesn't have any spalding from impact, so there's no debris caused by a debris impact. Obviously, up to a point, they don't really make it clear what that energy level is before it just kind of disintegrates, but it looks to be a lot more capable, a lot lighter, hopefully a lot cheaper, and it could be very valuable to a lot of our on-orbit assets. I could see the military being very interested in shielding some of these more high-value assets, and just getting us away from causing more debris is always great. So I hope qual testing goes great for them. I hope this is a new component that's available to system integrators. A couple other moves in space have been the Serpentrio, and Xona Space Systems partnership for high precision navigation for drones, autonomous robots, agriculture, and mining. Xona Space Systems is a lower Earth orbit kind of GPS augmentation system, and Serpentrio is a GPS subcomponent provider. So partnering together makes sense. If Xona is operating on a kind of new frequency that's meant to augment the GPS satellites already in orbit, they're going to need the chips to kind of support their system. So this makes sense that they're working together. They had a funding raise late last year, so hopefully they're getting close to deploying something that's more operational. This would be a huge benefit to the GPS system, not just for making it more accurate, but also making it more resilient, kind of looping back to what we were talking about at the beginning with just resiliency of proliferated networks. Having GPS supported from low Earth orbit and from medium Earth orbit will improve our system significantly.
One of the spaces that we looked at fairly extensively was the PNT/GPS position, navigation, and timing data / geospatial positioning satellite space, and how that industry was affected by the simple economic arbitrage found in contested communications or in GPS denied environments. For example, $50,000 jammer is able to more or less completely obfuscate any and all PNT or GNSS data streams into a particular area or zone, meaning that for anybody trying to solve high precision navigation, for anybody trying to solve anything autonomous, a simple $50,000 jammer, $5,000 jammer, what have you, can completely incapacitate a much more capital intensive asset. And so there is a massive market in solving these problems, and in solving these problems resiliently, such that that simple economic arbitrage can no longer be found. And I'm excited to see how Serpentrio and Xona Space Systems are able to sort of bridge this gap and solve the much more specific challenge of automating high fidelity and high precision navigation requirements in a resilient way.
Thank you, fellow Earthlings, for joining us in our corner of the universe to hear about all the exciting times in space this week on the Space Times podcast. I've been Harrison Lambert here with Paul Mayer, and we hope you enjoyed and will join us again next week.